Hello. Good afternoon. Can everybody hear me at the back? Yeah? Okay, great. Sounds good. So I'm Enwei. I actually been in the company for 16 years. Had a pleasure working with Catherine, for a while, especially in the storage space. Have spent most of my time actually in the R&D world. Just moved to Beijing last year to drive this organization in terms of engage with our developer and our ecosystem, really creating some new innovations in terms of application space on the platform. One of the additional roles actually I'm taking on since I moved to Beijing is really looking at the cloud, how do we actually landing cloud in China, in Greater China region. So it's my great pleasure today to come in front of this audience and having a dialogue. So I hope that we'll have some time left towards the end and for some interactive Q&A. So today I'm really going to share a little bit about Microsoft's cloud strategy. And as that strategy sort of rolling out, as we experimenting using some of the paradigm shift we see, and how does that really impact academic community, especially from a scientific research perspective. So let me get started. So there's a lot of buzz, in the industry as we're talking about cloud, as we're talking about what is the definition of cloud? Is that just the same, hosting business, and is that how different that is, compared to the grid computing or HPC and so on and so forth. So this is some of the things that, as we kind of enter into this space, actually Microsoft has been in that space for a while. If you're really looking at the set of consumer cloud services that we have been playing, and then some of the commercial cloud services that we have been pushing out in the last few years. So we're sort of taking a look at those and really asking ourselves, what is the cloud computing? What's some of the characteristics that cloud computing have demonstrated? So here's a few of those comments or definitions coming from the industry research groups. There's really few keywords sort of popping out. I think it's important to recognize in terms of scalable, in terms of elasticity, in terms of a business model, in terms of pay as you go, and also the requirement in terms of how do we standardize set of technologies, both from infrastructures to platforms to the application layers. So this is a set of things that, very in alignment in terms of what Microsoft has been, communicating in terms of, the cloud computing, in terms of some of the key characteristics we want to see both in the infrastructure as well as in the application space. Now, as we sort of talking about kind of theoretically in terms of what that definition really is, let me kind of quickly going through the set of scenarios. So in internal Microsoft, we start talking about workloads. So the question is really, why are we using cloud computing? Okay, now I'm more from the business side. As we sort of looking at the set of customer scenario, one of the things I step in a little bit in terms of the Internet of Things panel. Catherine sort of mentioned it's all about the customer. It's all about what the customer wanted in terms of the business operations they are facing or business challenge they are facing day in, day out. So here's some of the four distinct sort of workloads that we typically see. Okay, for the first one, in terms of on and off services, this is something that typically happens in the financial, business in terms of some of the financial report they are running and the forecast they are running after days of, transactions. And some of the growing fast businesses really kind of represent, especially in the internet edge, if you're looking at some of the web companies, looking at social network companies, e-commerce companies, we do see their rapid behavior as they accumulate customers and a user base. The demand and the stress on the back-end system kind of grow exponentially. And certainly some of the things that happens, due to disasters or due to potentially even some of the viral marketing activity, you might actually experience some of the unexpected peak. And certainly there are scenarios related to regular predictable business, like for instance, Christmas holiday going to come about. And I was just making a set of mermaid clothes for my daughter for the Halloween. It was interesting in the Shanghai's, clothes market that all the vendors knows that all the foreigners are rushing in October try to make those mermaid dresses for their, for the little girls, at home. So as we sort of encountering those scenarios, the things from the IT perspective, from the business perspective, I keep asking is that, how do I really grow my business more effectively, more efficiently, at the most cost-efficient manner? So this is really a time that we believe as a company that we're in this critical juncture. The new generation of IT, how it's being managed, how it's being planned, how it's being built, and how it's being deployed is going to be radically different as we move into the next stage. It does require a very scalable, elastic systems. It does require a set of new business and operating models that is very different than previous software-oriented paradigm. So as we look into those scenarios, certainly in the industry, we're talking a lot about in terms of a set of standard taxonomy to describe from technology perspective how do we enable those things. So let me sort of go through some of that. Microsoft take a deeper look at those and then try to provide some clarity, okay? So historically, I mean, everybody is familiar with this whole package of software mentality in terms of I'm bringing operating systems, I pay for the licenses, and all those things kind of listed from here in terms of network up to the application is all managed by the customer. It is customers' responsibility to operate, to develop new apps day in, day out. It is their responsibility. Now, as those customer scenarios I described earlier, this might not be the right model anymore moving forward. So one of the things, and certainly we have seen in the business is starting is, hey, how do I really building a scalable systems and then have the vendor to really manage some of the base infrastructures from the networks to the virtualization. Okay, that's sort of typically in the industry called infrastructure as a services. A typical example is if you're looking at Amazon's EC2, sort of falling into that category. But one of the things that's still required for application or application for the business is that they still have to manage the OS, they still have to manage all the runtimes, the middleware layers, they still have to spend a lot of time in terms of the business logic and applications. So the burden of the managing the OS is still resides in the application developers hand, also the business hand. Now, further on, there's a notion of a platform as a services. Okay, so that's the area we're basically saying, look, not only we're going to help you to managing some of the basic infrastructure, we're going to manage your OS, we're going to manage your runtimes and making sure that's fully scalable. We believe that application developers' focus really should be on what they know the best, is in that business scenarios, in that academic, scientific research scenarios, and really putting their head around those instead of worrying about backend infrastructure as runtimes. So that's actually a direction that certainly Microsoft is taking if you're thinking about a Windows Azure. As a platform, as a service, to bring all those management from the network to the runtime layer, and we're going to take care of for you, and really partnering with the community to really drive sort of a true application innovation in a new era. And then certainly the software as a service, truly having the entire stack as being run and being operated, by the vendor. So that's sort of a way that as we look into the industry-defined taxonomy and how do we see all those bits and pieces fit, okay? Now, we're talking about the scenarios, we're talking about the characteristics, we're talking about the industry taxonomy. So what exactly, Microsoft is offering, Microsoft is doing in those spaces? One of the things that everybody is very familiar with is our traditional, server platform. Okay, so those are the likes of Windows Server and the SQL Server, and the System Center and all the virtualization management stack. And some of the key things is that we still make that available. This is a very critical to some of the business, especially in the traditional software business, as well as even in the infrastructure as a service business. We have seen a large number of hosters, for example, and also private entity want to build their new generation of data centers. Using the server technology, using those commoditized hardwares, and then want that control, want that customization capabilities. So that's actually something that Microsoft has been working on, also providing a set of solutions. For instance, Dynamic Data Center Toolkit, as well as the self-service portal, really enable this set of scenarios for the customers. But even more importantly, we, since 2008, have launched this set of services platforms, more anchored around Windows, Azure, and also SQL Azure. And then that very platform has been operating, again, like I say, in the last couple of years. We launched it commercially end of 2009. So we've only been running this thing for the last less than a year. The results has been very significant, and we have more than 12,000 companies actually running and experimenting the Azure services, and we're continuously evolving this set of platforms on a very rapid pace. So as we let me kind of go through a bit more detail in terms of Azure platform. What is that? So there's really three key components. Okay, so there's a Windows Azure services. It is really a set of scalable compute and storage services. It's automatic service management and a set of familiar tools. And one of the things that's worthwhile to call out in terms of the storage space, there's for the persistent storage, there's three infrastructure we have been built into Windows Azure in the form of tables and blobs and also queues. And as we step forward, we actually introduced the SQL Azure. One of the important things is that's the only relational database services that is available today. Okay, so in addition to non-structured data storage that we have been providing in Windows Azure, one of the things that we feel is very important to bring that relational database forward. Part of the reason is also getting a lot of those existing commercial applications smoothly, easily transition from our on-premise world to an online services world, and how do we actually make that development experience continuous. And certainly there's a set of Azure Fabric. It's all about how do we get connecting existing apps to the cloud, and then making sure all those applications can work seamlessly across the network boundaries. So those are the new set of what we call services platform that we have bring into the marketplace to enable new generation of cloud application development. And in addition to that, a lot of people actually start worrying about it and say, hey, this is a new set of platforms, a little bit different than Windows Server and SQL Server and system management. What does that mean? What does that mean to my developer in terms of set of skill sets that are already built on the existing platform? So one of the things that the company is paying a lot of attention to is driving that continuity. So although this is a set of new platform, there's a set of common skill sets sort of persist across on-premise and online. So those are in the form of .NET technology, Visual Studio as a set of development tools, and certainly management, Active Directory, and etc. Those are all common across. One of the things company also spend a lot of effort is to recognize this needs to be an open platform. So in addition to the great support that we're going to have on the .NET languages, there's also a great support in terms of Javas and PHPs and Pythons, really kind of making that as open platform as possible to encourage the new generation of cloud application development, to the next level. Now, one of the things that we always believe within Microsoft is sort of, dog fooding your things. Okay, so and certainly there's sort of a new business needs. Now this is all about platform as a service. Now on top of platform, there's this layer of data. So one of the things today, we actually have a lot of challenges. From the application developer perspective, right? Very simple scenario, right? I want to take my wife out for a date in Beijing. Okay, usually what I will do, on my mobile phone, is a set of activities. I will take a look at, what's the best restaurant around, the area that I want to, take my wife to. I want to looking at the restaurant reviews. I want to looking at some of the activities potentially around that neighborhood, so that after the dinner I can take my wife to a show, to a play. And I also need to figure out from my home to those locations, how do I show the maps and all that stuff so that I can drive to that place in the shortest distance or shortest possible time frame. A lot of those data sets are available Okay, those are scattering around and then require me as an application developer go out sort of looking at those things and try to stitch them together if the application developer want to put together a composite web applications to support that scenario. So again, that's just a very simple, require a lower number of data sets. But as you go into the scientific communities, and if you go into some of the commercial scenarios, it is actually very important to have a mass amount of public trusted data or trusted commercial data available, and making sure that that developer can actively leverage those information at their fingertips, creating a new generation of context-aware and people-aware applications. With that in mind, we actually built a product, really sort of a data marketplace called Dallas, that are completely built on top of Windows Azure and Windows Azure platform. And it really helps to bring a lot of those credible public and private data sets into the bear and allow application developer to generate new set of applications that can be used on any platform, on any devices. And also, it enables some of the business opportunity for those data set owners. So that particularly in the form of data brokerage, to really connecting the actual need and the data source. And certainly on top of that, with the installation of those data sets, the set of BI capabilities in terms of analysis, in terms of reporting, can be done in a very seamless manner. So this is just another example in terms of cloud sort of bring a new possibilities to not only the end users, but also a vast amount of application developers. So now we saw a lot of things around the definitions and the scenarios and technology and what's the offerings. One of the things is a lot of people start asking those, how do we operate those? How do we operate those massively distributed systems to enable mass amount of customers to deal with massive amount of data sets? So this is actually something that Microsoft is being very proud of. This is an area that we have been operating for about last 15 years in terms of geo-located data centers. And we actually, we have more than those 6. Those are the 6 particularly used for provide Azure platform services. There's 2 in North America, there's 2 in Europe, and 2 in Asia. The 2 in Asia, one's in Singapore, the other one's in Hong Kong. And just giving everybody a sense of scale. I mean, those are massively amount of size of data center. Taking our the North Central data center in the U.S. In Chicago, this is actually a third generation data center that we actually putting forward. A container sort of infrastructure. It is in a space of 700,000 square feet. There are about 16 sort of a football stadium size. 50 to 60 containers. Each container runs about more than 2,000 servers. Okay, it's a highly condensed property with a lot of computing powers. And what's important there is that we actually do a lot of things to enable that set of infrastructure, managing this set of infrastructure, not only at the server level, but also the network, the electricities, and facilities. There's a mass amount of security effort sort of put in to making sure the data is secure and actually can provide services worldwide. So this is the type of investment the company has been putting in the last 15 years, and we're going to continuously putting a lot of effort to enable those infrastructures, allow application to grow into the next level. Now, one of the things is, as I've been in China, which is very interesting as to, it's a unique place. I think a lot of the cloud services sort of bring a new set of challenges to locations like China. As you might all know, besides the technical challenges, the additional set of challenges that cloud brings are really around operations as well as business models, but even more importantly is the policies. Okay, so this is a country that, like actually many other countries in Europe and worldwide, have a distinct definition or interest in terms of controlling and monitoring the data. The data sovereignties, as well as set of regulations to do with privacies and et cetera, is certainly very different. So one of the key things that, as we heard from our customers as well as the government saying, this is all great, this is a lot of infrastructures, but you know what, they're not here. They're not in China, they're not in my territory. How should I trust you, Microsoft, actually holding my customer, my commercial data? Okay, so that's a real situation, and that's a situation that is not unique to China, by the way. I think worldwide they have the similar, issues. So that's one of the things that I'm very excited about. In July this year in Washington D.C. in the Worldwide Partner Conference, Microsoft author, we actually announced this new line of capabilities. Okay, as you can see over here, Microsoft is already running a mass amount of data center networks to enable Windows Azure and SQL Azure services worldwide. And one of the things to understand those regulatory requirement and a policy requirement, Microsoft is actually offering a new set of scenarios where, how do we actually package those things up in partnership with our hardware vendors and our solution partners to bring it as appliance to connecting with our local service providers already been proven, right? For instance, in China, thinking about the telcos, even thinking about some of the large portals that is original, or even thinking about the government themselves. In Beijing, we actually have a large cloud initiative run by Beijing government. In Shanghai just announced a 3-year cloud plan. They're going to spend $500 million in the next 3 years to build out infrastructures. So thinking about how do we enable those technologies for the local service providers, really bring Azure services to a mass population. And certainly there's another scenario in terms of the customer. We actually have that scenario in eBay. That's actually one of the partner that we have announced in July. eBay basically say, what, this is actually great, but I want to manage all my IT. This is actually a great opportunity, for me to manage my IT. But I want to manage it by myself. I want to control all that stuff. Can you do that? So one of the things that we actually partner with eBay right now is bring that container infrastructure in eBay, the data center, as a way to replace the entire IT infrastructure moving forward. So those are the things that get me very excited in terms of the set of Azure capabilities, both from infrastructure to the platform layer, make it very interesting, and we extend it to the partner or service partners as well as end users through appliance to truly enable those scenarios while we comply with the policies and the regulations. Okay, so with that, so let me sort of pause for a second. So we talk a lot about the platforms, the technologies, and even some of the policy stuff. What are the paradigm shifts? What we have seen? Okay, so I'm going to call out a couple of things. This is not comprehensive or conclusive. I'm sure there are a lot more as we further into the cloud space, and I think this community, will learn a lot and will teach us a lot along the way as well. But a few of them certainly come up. I think I'm going to talk about two. One is certainly around scalability and elasticity. Okay, so I think we're moving away from a traditional managing one server or couple server, kind of a paradigm to managing thousands of server, tens of thousands of server. So the capability of managing that large quantity of infrastructure is huge. And all those things will have failures, and how do we actually deal with failures in the most responsive kind of way? And in addition to all the server management, what are other things that we have to pay attention to in terms of its usage patterns, in terms of performance, in terms of the connections to utilization, electricity, to the space, et cetera. And then certainly, how do you deal with a globally distributed network of those data centers. Those are all a very important, aspect of scalable and, the flexibility. What's important is really bring the management, requirement to the next level in terms of dealing with this massive amount of, infrastructures. And the second thing, so also, continue on with the scalability is that from an application perspective, there's a lot of needs in terms of I will be able to increase or decrease the resource, based on the needs, based on the demand, okay? So how do you actually enable, from the language perspective, architecture perspective, a much easier way of, quickly scale up and scale down your applications, not only at the instance level, but also in the form of databases, okay? Now, in addition to that, there's a whole bunch of requirements in terms of the state. How do you actually manage the startup of state, the state synchronizations, and managing state across those instances? And also really kind of rely on the queues and providing the grooves for the, the work that among the worker roles. Now, all those are really the new set of requirements for both application and infrastructure in the world of cloud computing in terms of enable elasticity, enable, the scale. Now, in addition to that, there's another key word a lot of people are talking about, really all about multi-tenancy, okay? So this is a part that often used in terms of, hey, how do I really reduce the cost by jamming multiple users in similar instance, okay? Now, there are a set of requirements in terms of the data partitioning and the synchronization becomes really a key, but even more importantly, in that kind of a paradigm, how do we ensure the tenant isolation to making sure their security and also minimize the impact. Okay, so one of the things that, in the scientific community, I worked on HPC a little bit and then suddenly getting a bit more exposure in the scientific computing. And certainly from dealing with a massive sort of a data intensive, calculation, the scientific community is actually moving ahead along with all the new computation, powers. One of the key challenges we're actually dealing with is that for the set of well-funded, large research organization, no problem. I can build my computing powers, data centers, what have you, to really run through all my researches. But for individual researchers or for small research organizations, sometimes doesn't have that luxury. So what they really kind of default to is either leverage some of the commodity clusters or reducing the size of researchers. So as we sort of thinking about cloud computing, as we're thinking about this set of pay-as-you-go, the low entry point getting to those infrastructure usage, is this really a new opportunity for us to sort of democratizing the researchers, enable the small research facility to able to leverage or use the true computing powers as a large research organization can enjoy? Now, as we're looking into this further, I have to say that we haven't really, this is still a very untapped, unexplored area. And one of the key challenges really, as we're thinking about scientific application, it has sort of unique characteristics. As we're looking at evaluating across the cloud computing platforms, including Microsoft our own platform as well as Amazon's and et cetera, when we design those platforms, it's not necessarily with scientific computing in mind as we design. We design it more for long-running web services, with sort of a moderate, intra-connectivity or intra-interaction, among the instance. However, the scientific computing is actually have a wide range coming from a CPU-intensive sort of set of a calculation that doesn't require a lot of interaction to fluid dynamics. If you're looking at fluid flow, analysis actually require tons of interaction. So it does capture a wide range of application types. And then BLAST seems to be, I don't have to really explain what BLAST is. I think this is the audience is very familiar with what that is. For bioinformatics research, and this is really a commonly used tool. We're actually looking at this one and say, hey, how do we, taking that example, it does reflect some of the classic scientific research problems. It is computationally intensive. It is very critical for bioinformatics work. it also embodies all the characteristics, or most of the characteristics, a scientific computing will represent. So in that space, we actually did quite a bit of work to build the Azure Blast, that is sort of a parallel engine that, completely leveraging, Windows Azure platform. And we took on the architecture design that really leveraged the queue, segmentation and also massive data parallelism to enable this set of scenarios, to really try to test out the performance and also the characteristics of the Azure platform, in that setting. So here's some of the details. If you're interested on the more architecture stuff, that we can actually do that offline. But here's some of the detailed number that we have gone through. Literally, this is, we're using worldwide computing powers from, Microsoft's, various data centers. There are thousands of instances, that have been deployed to really analyze and do a, all against all experiment, of all the sequences. And then if you do that on a single machine, I think the estimation is about, 6 over years. And in this particular setup, we did that in about 6 to 8 days. There was also some other numbers that we have been, tossing around in terms of, there have been, if you're having 5,000 new porting strings, and if you want to do a reference check and a comparison with reference database, again, in the traditional manner, it's hours and days, and in this particular setup, it took us about 30 minutes. And also there are some numbers like 5,000 porting against 5,000 different stream, and this is about 30-second computation. It does actually great amount of efficiency in terms of computing, great amount of efficiency in terms of bringing the actual research result more timely to the marketplace. So this is another example. It's actually done by our local team. There's a group of people sitting in this room. I'm sure they are more than happy to, spend some time with you and telling you all about, their experience. Zhang Zheng, can you raise your hand? I see you sitting at the back. Zhang Zheng, raise your hand. Okay, so people knows who you are. So talk to this gentleman if you want to know more about Sigma. So Sigma is really a machine learning set of algorithms. One of the things that was interesting is that if you think about Azure, Azure platform, like taking another example, as I was working on the HPC space, one of the examples that we're trying to figure out is there's a large amount of financial data existing, for instance, in the US. We actually did some study taking the last 10 years of US financial data across 8,000 banks. Okay, so those are publicly available data. And one of the things that from application, from a researcher perspective, is saying that instead of having me to touch those raw data, are there existing models that is available that already shared among research communities and et cetera? I can build on top of that. So very similar to this, I mean, there's a large number of machine learning algorithms and models that is available today. And how do I actually, using a cloud computing platform to making those set of models a lot easily shared across the community, allow communities to actually innovate on top of those things or adding new models into those. And so those are a few examples. If you're looking at Azure Blast, it's all about the scalability, the relevancy around the scientific communities, and also the new set of application design architecture required to use the cloud platform. And for the Sigma is really how do we bring those models or predefined models more broadly to the community, allow the new generation of innovation on top of that. So the key thing is really, this is call to action over here. We're excited. I mean, I think this is a great forum to get in front of all the top of mind in the academic space. To move this thing forward, okay? To move this thing forward, there's a lot of problem. We're continuously learning new tricks, in the cloud computing space. And we have some learnings we want to share as well as we're learning from the community. Some of the key ones is really about how do we get together to actually really understand some of the technical architectural challenges that cloud computing actually left on the table? To really partner through Microsoft research or through Microsoft in general, to taking further steps, making this thing real. And certainly teach distributed and scale programming classes in your classrooms. This is actually something that was very interesting in the, I think in the US, this already started in the cloud computing courseware. And in China, I know there are a few universities also start looking into courseware in terms of driving cloud computing capabilities in a new generation of computer science students. And they certainly build their own clouds or partner with Microsoft in terms of getting their hands-on experience. I mean, I think Azure Blast is a great experiment for us. Not only sort of it's cool, but also really learning a lot of nitty-gritty detail in terms of what the platform brings, what some of the key challenges this platform represent, what that platform good at, what's not so good at, and how do we continuously increase that. But I think come join this community and really focusing on your energy on the space that you are super good at or expertise at, and then partner with Microsoft to making sure that we have actual meaningful usage of cloud computing. We're not talking about concepts, we're not talking about definitions, we're talking about actual implementation, we're talking about actual usage to bring this set of services to the broader audience. With that, I think I'll manage time reasonably well. I have 10 minutes for some questions.
I'm from Hunan University. So I have a question. Right now, Azure is just as a platform as a service, right? Mm-hmm. So in the future, is there a plan for Microsoft to extend the Azure to the software as a service? What it means, right now maybe somebody talk about in the future we don't need an operating system in the computer. We just only maybe need a browser, something like this. All the software maybe just installed on the server. So is there any plan for Microsoft to use Azure as a software as a service, not just only the platform? Thank you.
Thanks for that question. I mean, the question around, whether or not Microsoft is actually extending Azure, to become a sort of a software as a service. And Microsoft do offer a set of software services, okay? So those are in the form of our Office line of products in terms of productivities. You think about a Windows Intune in terms of a set of online services for desktop management. And certainly dynamic CRMs, so we actually have a set of commercial usage of software as a service. Many of them will be migrate or start building on top of the Azure platform. So from the company perspective, we do offer things not only at the platform as a service layer, but also software as a service layer. And we're certainly looking forward to enable mass majority of third-party vendors to bring additional software as a service on top of that platform. Okay, so that's certainly is a plan, and we already have in deployment for the last year year or so, and there's some good take on those. There's a gentleman over there or over here.
I come from Beihang University, so I'm quite agree on one of the suggestions that we should promote the education for the programmers to write the scale-out applications or programs. So here I'd like to ask a question, is that in your opinion, the key difference of the say programming language or programming for the cloud platforms such as Azure when compared with C or C++ language, And the second question is more related to one talk this morning. Say, if we want to train the student to familiar with such kind of new programming model, so commonly speaking, we should give them a platform and they can try and so update something on the platform.
Sure.
So what do you think about how to promote this kind of training or education in universities?
Okay.
Thank you.
Great set of questions. I mean, this is actually, my team is quite a bit focusing on in places like China. So let me answer this. There's really two questions there. One is from the application architecture